Hello students, today's agenda is to check homework. We're going to be learning about population growth and population decay, and you will be able to work on 8.8. Today, students will be able to calculate population growth and decay from word problems. So here we have a scenario. It says California has a growth rate of 0.9% per year. In 2015, there was 38.8 million people. 3.8% growth are attributed to mini boom since 2010. Okay, so what we need to do first of all, whenever we have word problems for exponential functions, is to identify the initial point, the base, and also the cycle. Okay, so California has a growth rate of 0.9% per year. And here we see that what's happening is that the population is growing by 0.9%. When or how often? Every year. Okay, so we have the base and the cycle. So this is the base, or it's going to be part of the base actually. I'll show you in a minute. And then the cycle is every year. What is the initial point? What do we start with? We start in 2015 with 38.8 million people. And so how would you write a function? What is the function of this scenario? Well, we always have f of x. Remember that this can vary. You can actually say p of y, population for every year. Okay, so p of y, if you want to, equals the initial point, which is 38.8 million, is the same as 38,800,000 people. Okay, and the base, if we say that it's gonna be in decimal form, we would go always 2 spaces back, because percent, to get into a decimal, we just go back 2 spaces. This means for every 100%, for each 100. Okay, and basically means divide 0.9 by 100. If you use your calculator, let me see if you can see this in here. 0.9, yeah, I need to turn it on. 0.9 divided by 100 will give me 0.009. Now, some people will say, oh, the base is 0.009. And remember that for the exponent, we will always use the same variable here over the cycle. The cycle is every year, so we would put it over 1. In reality, we don't need that 1 in there, otherwise you're going to just be doing extra work if you include it. Okay, so what would we get if we multiply 38 million? Let's say that we want to know the population in 2016, 1 year later. Okay, so what would the population be in 2016? So that's 1 year later, right? That will be f of 1. So we will write f of 1 is equals to 38,800,000 times 0.009 to the 1. Okay, because it's f of 1, so we replace the x with 1. Again, we don't put the denominator 1 because we don't need it. So what do we get? Would this give me the population of 2016? Let's see. 38,800,000. And so we multiply times 0.009 to the power of 1. We don't really get any change, but I'm going to put power button to the power of 1 equals. And notice how the answer comes up to be, what is it? 349,200. Well, that doesn't make sense. If the population is growing 9%, how come I'm getting a smaller number? I'm getting 349,000 instead of 38 million plus the population growth. Well, guess what? We just killed 91% of the population. Okay, so what we need to do in reality is put a 1 in here, because that represents 1 time the population that already exists, plus the 0.9% population growth. Okay, so now that we do that, I want you to take notice of the number. Maybe I should write it in here on the side, because that should be the growth for the first year. Okay, that's how many new people are going to be in California 1 year later. Okay, so now this function will help us. Oh, and let me include this in here. This one represents the population that is already living in California in 2015. Okay, that's the people already there. And this represents like the additional 0.9% that is born or comes to California each year. Okay, so now let's do with the 1.009. So it's going to be 38,800,000 times 1.009 to the power of 1. Again, the power of 1 is not going to do any changes, but so the new population 1 year later is going to be a total of 39,149,200 people. Okay, that's how many people are going to be in California 1 year later. Okay, what if we say in 2020? How many people are there going to be in 2020? Again, we're going to put f of, now how many years have gone by 2020? Well, from 2015 to 2020, that's 5 years. So it's going to be f of 5. 5 years later, what's going to be the population? Okay, so f of 5 is equals to 38,800,000 times 1.009 to the 5th power. Again, this is going to include the population that the initial point, ones basically, plus the 0.9% growth, population growth per year, and it's going to be a total of 5 years, so that this is going to give me that growth per year. So again, I'm going to use my calculator, and so it's going to be 38,800,000 times 1.009, meaning the population that existed, plus the growth, the yearly growth, to the power of 5 years later. And I'm gonna have in 2000, if it continues to grow in the same way, it's gonna be 40,577,712. We're gonna round it because we cannot have pieces of people. Okay. So we're going to round to the nearest whole number. Okay, so if this is a 5, after the decimal, if this is a 5, 6, 7, 8, 9, then this goes to 13. But since this is less than 4, so a 4, a 3, 2, or 1, this stays the same. That's why we have the 2 in here. Okay, the whole number. Okay, what about how many people will there be in 6 months? Again, once we get the function, remembering that to look for the initial point, what's going to help us for the base, remember that when it's population growth, we always include the 1 for the people that already was there, and the growth we added to it in decimal form. Okay, so in 6 months, okay, so what is 6 months? If this is per year, the cycle is per year, what would be 6 months then? Well, some people will say 1/2 of the year, yes, or 0.5 of the year, same thing. Okay, so it's going to be f of 0.5 is equals to the initial point, which is 38,800,000 times 1.009 to the 0.5. Okay, 0.5 because it's only half of the year. 0.5 represents half, so half of the year. And so once we have it in there, we can just press our buttons. 38,800,000 times 1.009 to the power of, in here you have to be very careful because some people forget to put 0.5, just like it is. First the point and then the 5. Okay, you have to make sure that that's what it's in there, 0.5, and then equals. And so that means that 6 months later, after they took count of the people in 2015, the population was 38,974,200. In here, we notice that this is before the decimal, so the 9 is bigger than 5. Okay, so that means that it's going to be 2009. It rounds up. If this is 5, 6, 7, 8, or 9, then this becomes one more. Okay, again, with people, bacteria, animals, letters, all of those are going to be rounded to the whole number. When we're talking about elements or weight, then we can have decimal places, and I recommend when we have decimals to round up to the nearest hundredth. Okay, but in here, nearest whole number. Okay, let's do a tricky one. In 2014, why is this tricky? Well, in 2014, that was 1 year before they took count of the 38.8 million people. So if it's before, that's time in the past. And I would like you to think, how do we represent time in the past? Well, with negative numbers for x, right? So it's going to be, instead of x, it's going to be f of 1 year before will be -1. Okay, 1 year before, 1 year in the past is equals to 38,800,000 times 1.009. And this is amazing how this formula works, because we're going to get the population of 1 year before just by raising it to the -1. Okay, this represents 1 year before. So we have 38,800,000 times 1.009 to the power of -1. So in here, you have to be also very careful because it all depends on what kind of calculator you have. We press the power button. Then in my calculator, I'm going to press the 1 and then the button that says plus minus. Sometimes you will have calculators that have a key that has a minus in here. So that's the one that you might have to press. But notice how in my calculator, I press the 1 first, and then I'm going to press the positive negative button, and then the negative appears in there. Okay? And then I hit equal. So 1 year before, in 2014, the population was 38,453,915. Again, this makes the 4 go up 1 because it's greater than 5. Okay, so this is how many people there were. About 300, close to 350,000 less. Okay, 350,000 less people. Okay, so let's go to another scenario. Something came to mind, but I can't recall. Maybe I'll come back later with the other. Okay, so in here, because it's population growth, okay, population growth, we have 1 representing the population that already exists, plus the 0.9% in decimal form goes 1, 2 spaces, add 2 zeros, plus the 0.009, and that's equivalent to, you can easily do it, just put the 1 in here and that's your 1.009. But if you are confused, you can just use your calculator. 1 plus 0.009, which is the population growth, and it's equals to 1.009. So that's where this came from the one that is a population that already exists, the growth, and that's a total of 1.009. That's your base. Okay, so the 1 plus the growth, and that's the 1.009 that we use for the growth. And so I'm showing you this because it's going to be very crucial or important for us to understand where that base came from. The population that exists plus the growth. Okay? Now let's look at this new scenario. It says in 2015, Spain has a population of 47.6 million. Spain has a population decline. This is the keyword, decline of 18.3 per decade. Okay, this is the another thing. Decade, it's every 10 years. So immediately you can see that every 10 years, when we're talking about how often it happens, we're talking about the cycle. Decline, what is happening to it, it's basically your pattern, what's happening, right? So this is going to be part of the base. However, it's decline, and you'll see what we're going to do with that. And what's our initial point? What do we start with? Well, we start with a population of 47.6 million people in 2015. Okay, so we already have our initial point. Remember that it is very crucial that you guys are able to identify what is the initial point, what is happening to that initial point, and how often. That's initial point. The base is what's happening to that initial point, and how often, that's my cycle. Okay, so how do you write the function? Remember that I told you that it's important to know what's going on. I'm going to show you something in here. Okay, so it says that the population is declining by 18.3%. That's the people that die and leave from Spain. Altogether, that's how many leave. So we start, okay, this is important. We start with a 1, which represents the population that already exists. But then people leave or die. So minus, we're going to subtract these people that are either living or dying. And remember that we have to put it in decimal form, so it's going to move 2 spaces to the left. So we're going to subtract from the population that exists 0.183. That's the 18.3%, okay, that are living or dying in Spain. And so my base will be equals to 1 minus 0.183 is equals to 0.817. So that's going to be my base. Again, why did we subtract? Because this represents the population that already is in Spain, and this is the population that are either living or dying. Okay, so that's why we have to subtract it, and whatever is left, that's what the population that is going to continue to live the following year and the following year. So it's basically 81% stays in Spain. Okay, so what is the function? Well, f of x, and we can also use population per decade. Remember that this represents kind of like what's the cycle? We're talking about decades, okay? Or we can just put f of x if you wish. Okay, so f of x is equals to the initial point, which is 47,600,000 times the base, which we already found is the population that exists minus the ones that are going to leave or are not going to be there anymore. So that's left with 0.817. In class, somebody asked me, teacher, where is the 1? I said, well, the 1 minus the people that leave, you're including it in here. And this is the result, so that's your base. Okay? In California, this is the 1, but then since it was growth, you put plus because you're adding, it's growing, so you're adding. In here you're subtracting, okay? And that's why your base ended up from adding 1 plus the growth. In here your base is going to be from 1 minus the decline, okay? And now in here, every 10 years, because it's decade, so it's going to be x over 10. Okay, so x over, and it's every 10 years, so you put it over 10. Wow. Okay, that took a little long, but I just want to make sure that you really pick it up, okay? Okay, so how many people will there be, same, in 2020? How many people will there be in 2020? Well, that's 5 years from now, right? 5 years. So that's going to be our x. So it's going to be f of 5 is equals to the initial point, which is 47,600,000, and we're going to multiply by our initial point, which is 0.817, which is the population that remains in Spain, and to the 5 over 10. Some people are still getting confused with this part of the cycle. This just replaces the x. This 5 replaces x in here and x in here, but everything else stays the same. Your initial point is going to be the same. Your base will be the same. Your cycle will be the same. You're just replacing the number on top of your cycle. Okay? And so now we're ready to use our calculator. It's going to be 47,600,000 times 0.817 to the power of, oh, I forgot to divide. 5 divided by 10 is 1/2, which is equals to 0.5, because we're gonna need it in decimal form so that it's easier in here. Okay, so to the power of 0.5. Make sure that you include that 0.5. Okay, 0.5 equals, and so this is going to be the population. Remember that it's declining, so now we're going to have 5 years later there's going to be 43 million, assuming that the decline will continue to be the same. Okay, it's 43,024,713. We round up because this is the number after the decimal is a 9. Okay, so that's how many people there are going to be after half a decade. That's what this means, half of a decade. Okay, how many people will there be in 2050? So in 2050, well, 2050, that's 35 years later. So we're going to put f of 35 is equals to, I'm not going to use the same colors, but you know that the first one is initial point, then the base. 47,600,000 times 0.817. And in here, we're going to put 35 divided by 10. For some of you, you know that you just move your decimal back. But again, if you are not sure, you can use your calculator. And so 35 divided by 10 is equals to 3.5. Okay? We want to simplify that before we start putting the function or all the parts into the calculator. So it's going to be 47,600,000 times 0.817 to the power of 3.5. 3.5 equals. So in 2050, the population will be 23,463,000. 30, it rounds up, so it's going to be 33 people. And that's assuming that it will continue to decline by 18.3%, okay, per decade. Let's do one more. Let's do one tricky one. What about 30 years before? That means, if you think about it, if this is the population in 2015, 30 years before would be 1985. Okay, what was the population if, assuming that the decline had been the same, what was the population in Spain in 1985? Okay, remember that when we're talking about time in the past, that will be represented by a negative input, so negative 30 is equals to 47,600,000 times 0.817 to the negative 30 over 10. When we divide negative 30 by 10, that will be negative divided by positive is negative, and 30 divided by 10 is 3. Okay, so that's going to be my number that I'm going to use as an exponent. So, again, I put the initial point, which is 47,600,000, times my base, 0.817. Make sure you put the decimal point in the correct place, to the power of negative 3. But remember that I have to do it backwards in my calculator. Yours might be in the right order. You might have to put the negative and then the 3, and your answer will come out correctly. So check my answer and then try it with your calculator, because you might have to do negative first, number second, but for me it's number first and then the negative. Okay, so to the power of 3, and then press the negative, equals. And so that means that 30 years before, there was 87,285,235 people. Whoa, that's a big increase. Okay, notice how it was bigger since it was a decline, so that means that in the past there were a lot more people. Again, assuming that the decline had been the same. Okay, so with this, you're able to now work on 8.8, sorry. And yeah, remember just that for your calculator, depending on how it is, it might be different for each one. You're gonna have first the initial point in your calculator, then you're gonna have times, then you're gonna click the base, then you're gonna click the power button, and I'm gonna put it to the side just because I'm gonna have several of them. Power button. I don't remember, sorry. I should put the power key. And it might be X to the Y, or it might be Y to the X, or it might be a little arrow like that, or an X to the, and then there's like a little white square in there. Okay, so either one of these ones are going to be your power button. Then you're going to put the exponent, and then finally you're going to put the equal sign. So for the example in here that we use, I'll use the last one. We would punch, let me see, I would put in here the 47,600,000. Then we would click the times, then the base, which is 0.817, making sure that I put the point first and then the 8 and 1 and 7. Then the power button, then the exponent in decimal form, and then finally the equal. So in here it would be, for my calculator, I would put the 3 first and the negative second. Okay, 3 and then negative, making sure that I put negative, okay, not the minus, because notice how we have the plus minus in here, positive negative, and then the minus in here. We don't use this one, we use the plus minus. Okay, so have fun doing 8.8.